Hello and welcome to another episode of Momento Malum today. Timothy is a forage crop that belongs to the grass family. Timothy is a cross-pollinating hexaploid crop. It is also a long day plant, which requires a day length between 13 to 16.5 hours for flowering to happen. The hours vary between different cultivars and genotypes, and lines from higher altitudes are adapted for longer day lengths than the ones from the lower latitudes. The majority of the land in agriculture is dedicated for forage and animal feed. Among the forages, Timothy is one of the most commonly used species, both for hay and pasture. This episode will cover 2 papers on Timothy breeding. Let's get started. Dr. Issa of the Swedish University of Agricultural Sciences will gather many papers on Timothy breeding to create a template to breed new cultivars in Poland, and here are the results. The comparatively few studies available on the topic of Timothy were focused on genotypes that are adapted to Poland, Canada, and Finland. Using this data, he would generate genotype by environment interaction models, which would show how different lines would react to different environments, the biological processes of these traits, and the heritability of these traits. The study involved the evaluation of 266 modern varieties of Timothy using this methodology. In Poland, Timothy is harvested 3 times per year. It was discovered that the greatest yield is gained on the second cut. The traits associated with the second cut of the Timothy is highly heritable. As such, Dr. Issa would suggest using cultivars with high yield in a second cut as breeding stock. It was also found that increasing the number of growing degree days also increases yield. So Dr. Issa would suggest increasing the number of growing degree days needed to reach maturity within the cultivars. This only works in regions with a longer growing season with warmer climates. It was also found that increasing yield via growing degree days would also reduce protein and increase fiber content within the yield. The inverse happened when the amount of growing degree days needed for maturity was reduced, although it came at the expense of yield. If you want to donate to my channel, the links are below. If you want to buy my book, you can also find that link in the description box below. Another member of the Swedish University of Agricultural Sciences was Dr. Rahimi, who would use phenotypic variation in both domesticated and wild Timothy and several closely related species to analyze the variation and traits within these lines. 212 lines of Timothy were analyzed. These were wild, domesticated, and hybrids between both wild and domesticated species. Wild relatives were also used. 14 of these were another subspecies of Timothy, known as Nodosum Timothy, and 18 lines of another species of Timothy called the Mountain Timothy. It was found that all groups of domesticated, wild, and hybrid Timothy had significantly higher yield than the Nodosum Timothy and Mountain Timothy in the field. It was also found, however, that Nodosum Timothy formed taller tillers than the Mountain Timothy. The greater growth of Timothy was expected due to a long history as a high-yield forage crop. Mountain Timothy seems to increase in yield under environments that support a longer photo period. Nodosum Timothy was not as plastic to the environment as either of the other species. The undomesticated wild Timothy showed vigorous growth and high yield, even though it was not domesticated. This means that the domestication process involved the improvement of other traits rather than yield increase when Timothy was first domesticated. Strange genetic lines were also found with suppressed flowering causing yield increases. Nodosum Timothy was also found to be very adaptable in low altitudes. This combined with the fact that all 3 species can crossbreed to make fertile offspring grants a great many possibilities for future breeding programs when it comes to Timothy breeding. And that will covers everything. Thank you for watching.